Hi guys, another of the emerald out. A long helix made of thin wire is held vertical. The radius and pitch of the helix are r and rho must be p. They have just let them go. I'll call it a p respectively. And bead begins to slide down the helix. Begins. Okay. So initial velocity was 0. Find the normal force applied by the wire on the bead when the speed of the bead is v. Yeah, so the bead is sliding down the helix. What is the inclination of the helix? If you look at any two consequent say the ring part, then what is the distance between them? P. You turn it around 360 degree, turn it once, and you will feel that this has gone over there, this part has gone over there. So this inclination after turning a 360 degree, so this round length is a sorry, I should make it like this. So when you are turning 360 degree, this is the length you are turning, and 2 pi r is the horizontal length what you see when you turn, and it has gone up by p. So this is your inclination of the helix. Try to imagine a bit. Now it is sliding down, so it is sliding down with over here is the bead, it is sliding down with the v velocity, and they are asking find the normal force applied by the wire on the bead when the speed of the bead is v. So one is the normal force is going to come due to the weight, so your weight is downwards. Mg, so it will have a component this way which is mg cos theta, and the normal reaction is going to be due to that. And secondly, the bead is going round, and if we see the flat circle, the center of the circle which is say r deep from in here, then the bead has got a horizontal velocity of v cos theta. Imagine the helix was really having a very high pitch, and the bead is going downwards with v. How much is the centripetal acceleration? Like if the bead is really sliding down straight away with v, it has got no centripetal acceleration. The vertical component of this bead going down is not going in a circle. Only the horizontal component is going in a circle. So this v cos theta is the horizontal component, and it has got a centripetal acceleration towards the inside. It in terms of pseudo, it feels a force outwards of mv square cos square theta by r. So there's a reaction to that, and the normal force is providing the centripetal acceleration, or in pseudo frame we can say the normal force is countering the centrifugal force outward. So there is a normal force inside which is definitely 90 degree to n1, because n1 is in this frame and the normal force is the n2 is inside, and this is your n1. So hence the net normal reaction would be a n1 square plus n2 square. So that is what we have done over here, n1 square plus n2 square whole under root, and that will give you the normal reaction, which is part A of the question. Eventually the bead acquires a constant speed. So they are seeing that the bead has acquired a constant speed while it is going down, and that is v naught. It would have acquired a constant speed if the force along this incline, that force is 0, right? Now, what is the force along the incline? The force along the incline would be equal to 1 mg sine theta, and the other one is the friction backwards. So friction backwards and mg sine theta along the incline. So the friction would be obviously your mu times n. So the friction needs to be equal to mg sine theta if velocity is constant for net external force along the incline. By the way, obviously there is a centripetal force is there and it's taking the round. External force along the incline is equal to 0, so F minus mg sine theta is equal to 0. So the friction must be equal to mg sine theta. Friction is nothing but mu times the normal force, so this normal force times mu is equal to mg sine theta gives you your answer for mu. Thank you.